I'm Doug Fearn, and this is my take on music recording. Tad Rollow is a research engineer who has worked at companies like Eventide, Avid-DigiDesign, and Sennheiser. You probably own hardware or software whose design Tad has been part of. Tad has a wide range of interests and experiences, including hardware, software, and chip design. He's been recording music since high school and continues to do that. He has a degree in electrical engineering and a PhD in acoustics. Tad understands the intersection between engineering and art and knows that a product not only has to have great specifications, but it also must sound good. We've been friends since we met in 1981. I'd like to start out with just a little story about how you and I met, which I think is kind of interesting and unusual, because we actually met through amateur radio and using Morse code, which if you have heard the episode I did on what Morse code taught me about recording, you'll remember I spoke a little bit about the traffic handling and working with really good CW operators. And that's how I met Tad. And you were in high school, I guess, at the time, weren't you?
I was, yeah, and spending a lot of time handling traffic and really enjoying exactly that, working with really good Morse operators, and there's a real flow to it, a really good feeling to being on the air and just being really conversational. I think there's sort of a baseline speed above which it feels like a better flow, so I remember having that. But I also knew that you were a very experienced traffic handler, and talking with you I was barely keeping up, but it was a lot of fun. But I don't think I knew ahead of time that you had a recording studio. I think that just came up in conversation.
I guess we had conversations on the air using the code, but I do remember getting into that discussion about audio and your interest in it, and I remember inviting you over to the studio.
Right. In my mind, it sounds like a cool story if you invited me over entirely on the air in Morse code without us ever having spoken by voice ahead of time. But I certainly don't remember the details. But it was such an interesting invitation to me because my experience with audio was completely, I was using a reel-to-reel tape deck, but, an old Sony consumer reel-to-reel deck, and the concept of a recording studio was completely foreign in my direct experience. As this is true for many studios, it's a sort of a nondescript door and a nondescript building, and me ringing this doorbell. And the entire environment, the whole vibe was really cool. It was really nice people having a really good time making music, but doing it in a really professional context. It was really cool that way. But the thing that really struck me was when you hit play on, and I believe you had a 3M, maybe it was a 16-track, but anyways, a 2-inch machine, and watching that machine start to roll and hearing the reproduction, I was floored. I had never heard recorded music sound that good. It was completely unlike listening to a commercial release, because it's before all of the stuff that happens when it's processed, and that was really neat. And of course, I know now that your studio was probably quite exceptional in its sound quality anyway. So I had a couple of levels of shock there in terms of sound quality.
Yeah, I think this must have been around 1980. Yeah, so the machine we had then was a 3M M79. It was a 24-track. And I have to say, I can't remember the specific session where you were. I really don't remember it at all.
No, I'm sure not. That's funny. But, what I remember about that machine, and this is why I think it's an isoloop machine, is that the lifters and the I think of them as like the tape head shields, I guess, on the isoloop machines have this really interesting sort of folding up action when you hit play. It was just wild to watch. It's really interesting. So watching tape handling like that was obviously a significant event for me, and I love analog machines to this day, and I love working with them. It's really neat.
I guess I can take at least a little bit of credit for your career choice then.
Oh, absolutely. I think that just lit me up, and of course it was many years later that I feel like I shifted into audio in a career sense, because I certainly throughout college expected to work in telecommunications, and I was studying signal processing for communication systems, and I think a lot of that was really born out of my interest in ham radio and my direct experience with it. And doing digital transmission on shortwave radio is an interesting challenge. It's a huge technical challenge, and I had a lot of fun with that sort of stuff with what would now be certainly seen as vintage equipment. But I had an ASR33 teleprinter. I used a VIC-20 to do ASCII to Baudot conversion, and then frequency shift keyed a tube transmitter. So I was doing all this interesting ham radio data stuff back then, and then in college worked in the summertime for Intelsat, which is a consortium of countries that operate a telecommunications network of satellites. So it was really cool stuff to me, and I didn't assume that I was having an audio career at all, and yet the experience in your studio and the experience with sound of that emotional depth was really significant to me. And when I left college, I went to work for Eventide instead of working in the aerospace industry. That I remember being sort of this major choice, like, oh, if I go in this direction, what am I doing here? It was really neat. And at Eventide, my job was not in the audio department. I worked in the avionics department. Eventide's a very unusual company. There's an avionics division, and I worked on a C and 68,000 assembly software package for TCAS traffic avoidance for small airplanes. It was kind of funny, given that it was Eventide and quite an audio company even at the time, of course.
I guess it was because, I can't think of his name, the owner of Eventide was a pilot. I guess that's how he got into the avionics side of it. But those avionics products were pretty innovative for their time. They were ahead of everybody else in some of that stuff.
They were. I'm told that it's the first, what's it called? Is it called private aviation when people are flying small planes on their own as opposed to commercial aviation? But Richard Factor is the owner of Eventide, and was sufficiently successful in his business that his hobby for flying grew, but he wanted more features. He wanted a map in his airplane, and he said, well, I'm not able to get one of these. Why don't I hire some people to make this for me? And it's a neat way for a company to grow. I hope I'm not telling the story inaccurately, but it was quite an innovative device. It was before GPS, or at least before GPS was common in private aircraft. And I remember we would feed LORAN simulators into the moving map, and it was a CRT-based map, so it was a gorgeous display. It became quite a successful product line, I think.
Yeah, it was very expensive too, because I remember when I was a pilot during that time, it was pretty much priced out of my price range.
Yeah, it was not cheap. But the audio folks in that company were super friendly, and they're, friends to this day. And, we all hung out together, and of course they knew I was interested in audio, and I spent a lot of time in the various recording studios and just in the laboratories there. Really was inspired by that quite a bit. And after a number of years at Eventide, I realized that I was particularly interested in audio signal processing. I mean, I continued my interest in that. But I was also curious where those signals were coming from and where they were going to. And instead of pursuing electrical engineering as a follow-on, as my undergraduate studies had been, I found myself drawn to acoustics and the physics of sound, even before it hits the transducer. Because I think in each of these real-time signal processing situations, it felt like these, you get one or two channels of audio, and, where is it coming from? And the physical sound field is much more multidimensional than that. And going off to study the physics of that was really a lot of fun. It was a big decision to leave my job, though, because I suddenly, I was choosing to have suddenly no salary and go back to a student life. But it was a big and fun transition.
For a lot of the people I talk to in the industry who are, very successful at what they do, there's really not much of a requirement for formal education because although it's a technical field, it's really an artistic field. And although some people these days go to a formal program to learn the art of recording, it isn't really strictly necessary. But on the other hand, the career path that you chose in audio does require that. And I think it's important to have you explain the education path that you took. And you've talked about that a little bit, but because I run into people all the time as interns, who are interested in getting into the technical end of the audio world. And I think this would be helpful to them to hear your story.
Yeah, it's interesting because I certainly, have to look back and recognize it wasn't exactly a predetermined path or something that I knew I was doing at the time. I think I'm really lucky to just see that it was the way to pursue the depth of interest that I had. And, as I was saying about aerospace and telecommunications, that's what brought me to a formal course of study in electrical engineering as an undergraduate. So it felt like the thing I should be doing because I was already doing it through amateur radio, perhaps, or through the study of electronics. It didn't occur to me that I would do anything else, which is a very lucky position to be in. I know a lot of people are curious about where they should go to satisfy a goal, but in this case, I thought, well, I'm building things and designing things, and here's an academic course of study that supports that. So it was a little strange for me to start off in college and realize that there were many people in my classes that had never built anything before. I mean, it was kind of a surprise. And of course, it's quite okay. There's lots of great reasons to get an engineering education that don't necessarily lead you to the practice of engineering. But for me, it was natural, and I loved the rigorous mathematics part coupled with the laboratory part. And the laboratory part always cracked me up. The people near me, blowing stuff up, smoke's coming out everywhere, and I'm like, oh yeah, I've done that. It just happened to be 5 years before I got into school, But certainly there were people I went to school with where I think, oh, I hope they never design an elevator or an airplane or whatever, But that's fine. I think the course of study is good for lots of different reasons. But for me, it went right into design engineering, and along the way, I found different interests than those that I would expect. For instance, an interest in digital electronics and computer architecture was completely unexpected, given how much I was into analog electronics through amateur radio and RF electronics and signal processing. But as I encountered computer architecture courses, that was really significant to me. And my senior project was I called it a reverb simulator, but specifically it was a real-time DSP board as a coprocessor board for a PC, and it ran a Texas Instruments fixed-point DSP processor on it that was far, far faster than the host computer. But I didn't actually know that much about reverb as an acoustic simulation. I mean, I was more focused on how do you make a computer, a fast computer. And so Eventide was very interesting for me in seeing people applying signal processing directly to music. And the reason I mention this is that going between the academic study and then the practice of building things that are useful was important. I'm glad I didn't go right to grad school. And seeing the cool tricks and the practice of building commercial products was really significant to me. It's one thing to have to do an FFT for a homework assignment, and it's quite different to to reliably ship that as a product. So that was neat, but I was glad to go back to academia for grad school to study acoustics. But by then I'd been writing assembly code and C code for some years and had to go right back into the calculus, and it was really intimidating. I thought, oh my goodness, how do I do this again? I have to relearn it. But it came back quickly. What I found about the study of acoustics, and this may be unique to the program at Penn State, but I don't know, is that each person coming into that program had a slightly different background. And acoustics itself is so multidisciplinary. My classmates were coming from mechanical engineering in some cases, a course of study in music, and a more liberal arts education, architecture, and study of building design and things like that, of course, was a big motivator for some people. And there were a fair number of people from the Navy who were doing sonar work, and we were all put in the same classroom learning about the fundamentals of acoustics right from the start, without any assumption that we knew what we were doing. And it was very challenging. I had always been intimidated by mechanical engineering because I took an electrical engineering-centric point of view. And a lot of the mechanical engineers were intimidated by the electrical circuit part. So we all jumped in together, started off with the wave equation, and off you go.
Well, I remember when you were in grad school, you invited me out to Penn State, arranged for me to do a talk to some of your acoustic colleagues.
Right. We founded the Penn State chapter of AES. That was a small local chapter that I started with another friend there. That was neat to have you come talk to us. Yeah, I remember that.
Well, what I remember about that was was a great bunch of people, for sure. But I got questions from that group of people that had never occurred to me. I think because of all their varied backgrounds. I remember specifically one of them because somebody said, why don't you match the impedance of a microphone to the input of the microphone preamplifier? Because they were working in, I guess, sonar or ultrasonic.
Yeah, it's very common for a sonar transducer to have a careful impedance match, right? Right.
Yeah, because they're basically dealing with a single frequency or a very limited range of frequencies, where it makes perfect sense. So I remember asking that question and standing up there in front of these people and like having this moment of panic, like, why do we do that?
Why do we do that? And yet you come from a broadcast environment of sufficient depth that back when there really were 600 ohm lines running around a studio, and that was in fact more common than today. Like if there's anyone qualified to answer that, you can go back and say, well, once upon a time, microphones really were impedance matched.
Yep. And there were so many interesting things that those people had. The perspective was great for me.
Yeah.
But I know that you had a really interesting project for your PhD. Talk a little bit about that.
Yeah, it's interesting how that fed my interest in microphones specifically because of the commonality there. I worked on an active control problem. Penn State was very active in active noise control, specifically control of acoustic fields it's often studied in ducts because ducts are nominally one-dimensional, but also because you can control exhaust noise. And then control of vibrating structures is interesting for lots of reasons, among them military. You don't want submarines to radiate sound. But overall control systems in general is a broad class of problems. It's very interesting. And in my case, I thought it would be interesting to modify the radiation of a kettle drum, a timpani, by changing the air loading of the bottom surface of the drum head. And so as the drum head is struck with the stick on the top, it vibrates, and the copper kettle is enclosing air below the drum head, which causes the overtones to be in a certain pattern. And by putting an array of loudspeakers below the drumhead, I was able to control the vibration of the drumhead after it was struck. So it's a problem that was interesting from its physics point of view because it's vibrating structures that are fluid loaded, the fluid in this case being air. And from a control system point of view, it's interesting because it's an array of sensors. I had accelerometers on the drum head and this multi-dimensional control array of loudspeakers. And then it's also interesting as an acoustic radiation problem. What is the resulting acoustic field that comes off the drum head? So that kept leading me down tangent upon tangent as I became interested in different parts of that problem. And I think it's a hallmark of many PhDs that when you start off thinking you're going to study a certain problem, you end up creating far more questions for yourself than you started with, and thinking, oh wow, this has been a mistake. It was a really neat thing to pursue. And the reason I connect this with microphones, of course, is that microphones are a vibrating, air-loaded diaphragm in many cases. I mean, the canonical condenser microphone is certainly that way. And the air loading on a microphone diaphragm is an interesting and complex physics problem. I have not actually had the opportunity to work directly on that in industry because there aren't that many people who design microphone capsules, and pretty much they're really good at what they do, and they already do it. So it's not like I suddenly get a job being a microphone capsule designer, but there's lots of reasons behind that. I think that my experience in computer architecture and systems architecture is proven to be another component of my work. So this mixture of physics and systems architecture is kind of bizarre, but the PhD was also fun because I physically built the thing and I also simulated it and did real-time programming. So I just sort of indulged myself, and I was very lucky to be able to indulge in that. And that's part of what academia offers is quite a bit of indulgence. But at a certain point, I thought maybe getting a job would be a really good idea. So I had to finish up. Yeah.
Maybe lead us through some of those early jobs that you did and, give us a sense of what each contributed to your body of knowledge and then build upon it for the next job.
Yeah, I think, this shift from industry when I was working at Eventide back into school, into academia, was one big leap. And then I certainly thought getting a PhD in acoustics was going to lead me to a job in acoustics. And so certainly that was my expectation in leaving school. But I was offered an opportunity to work on a graphics chip. I guess we now call them GPUs. But it was a very powerful GPU made by a company called Silicon Graphics, which was making graphics supercomputers. And I used those in grad school to visualize acoustic fields and draw these animated acoustic field visualizations, which are really a lot of fun and a great way to explore the physics. And I was so enamored with these particular computers that when I was offered a job to work on the chips themselves, I said, well, yeah, that's pretty cool. And it was a surprise to me because as an electrical engineer, I had specifically not pursued semiconductors and digital design. I had seen a number of other people doing it, and I was like, well, that's not my thing. My thing is signal processing or whatever. But it was a spectacularly complex device, and we worked on it for a long time, and I had to ramp up really quickly. I mean, I didn't fake my way into it, but it certainly wasn't my academic background, so it felt like a good expression of faith in my ability, but I sure had to do a lot of fast learning there. And then that led into a job working on wireless network chips, which was completely tangential but very exciting for how fast-paced it was. And around then I actually took some time to finish my dissertation because I had not actually graduated yet. So I did that and then went to Avid or DigiDesign. We weren't branded Avid at the time, and worked on ProTools, which was a swing back into audio, but in that case directly on the software side. So I was hired as a software engineer there rather than a chip designer. It's not like I'd expect otherwise, but I think it's very common in industry to be sort of labeled a software person or labeled a hardware person or whatever. And I've been lucky to bounce between the two, but it certainly causes confusion in meetings sometimes, when the software guy shows up at a hardware meeting and actually has opinions. People say, well, why are you here? What is this all about? But I was involved in the early days of Pro Tools HD when we were going from the old 888 systems to the Pro Tools HD system, and wrote software in that context for a number of years, and then worked on the venue class of digital mixing desks, the live desks, and I think that was the latter part of my career at Avid, probably a good 5 or 6 years working on that. Those were fun because it was a big array of real-time DSPs, and had to be robust in a live sound setting. There's nothing like hearing a bug when it's pushed through a 70 kilowatt PA. You say, oh, that sounds wrong. It's a really interesting environment in which to evaluate an algorithm. But that was a lot of fun. It was a really close-knit team and a really innovative product.
Well, I remember coming out there and visiting you. I guess it was AES show was in San Francisco, and we hung out together, spent some time together. And you gave me a tour of DigiDesign, which was fascinating. It was such an interesting place with so many people doing so many interesting things. But I have to say, my impression walking in there was that this was, like a dorm room of a bunch of musical, electrical nerds.
It really was a very playful space, very, very technically deep people, but with a lot of passion for audio. And
I was really impressed that virtually everybody's office had instruments in it.
Oh, that's right. Yeah, I guess that's absolutely correct. And, it's a lot of fun to work on something and then try it out, directly right there and say, is this working for me? And there's certainly some burnout to it as well. I mean, I would leave that job at the end of the day, and the last thing I wanted to do is go home and mess around in the studio. It just was not the space I was in. So in many ways, my work at Silicon Graphics and at Theros was actually a pretty neat opportunity to be doing music on my own while my day job was deeply technical, but not music related. But yeah, I think everyone at DigiDesign felt very lucky to work on the very tools that we wanted to use for our own creative processes and to make them as good as possible for that. There's a lot of passion behind the meetings in which we talked about the features and how it should work, and then there's a lot of really tough nuts and bolts under the hood that's no different in that class of products than it is in any other technical computer endeavor. I mean, you've got a whole bunch of digital systems running at high speed, and it needs to work. So that was certainly always a real part of it, that it didn't matter what it was being used for. It's kind of funny that architecture would be very good for all sorts of scientific applications. I think scientific real-time computing and music computing has had a little bit less overlap than I'd ever expect. I figured that all the stuff used for sonar and all the stuff used for music recording and the stuff used for medical ultrasound and just to pick 3 examples, are all very similar architecturally. But those businesses don't overlap very much.
Yeah, I always think it's very interesting that the whole universe works on the same rules, no matter what the...
It does. That's right. I mean, that I think is one of the fun things about physics for me is it's not an engineering problem. The physics is going to be what it is, independent of people influencing it. But engineering is the process of turning that into some result that you want for some outcome, and that's a fascinating collaboration with nature, and also at times a struggle. And it's amazing we can do what we do. But
well, that time you spent at DigiDesign, was that when you really had the opportunity to get into the recording end of it?
Well, I think even when we met over the air in the early '80s, I was recording, I would say, bands of I was recording my friends who were playing in cover bands or writing their own songs, I guess. But I was recording with the consumer quarter track reel-to-reel, and microphones of no great significance at all. So it wasn't very good, but it was a lot of fun. And I don't think I ever took the leap to do recording professionally until way, way later. And I think I was just too intimidated by it. It just felt like it was too big, and to do it well, I would need to have access to equipment I just didn't have access to. And of course, it's a silly thing in retrospect, because I look at how many people have brought themselves up step by step into very good recordings with simple equipment. But I don't think I knew that at the time. And given the access that I had to supercomputers and stuff like that, I clearly could do things with, a high capital investment. It just was other people's gear. So I do regret that I wasn't directly working in studios earlier than I did. But certainly at the time I went to grad school, I started to accumulate analog tape machines, and I had a 1-inch, I still have it, and a 1-inch Ampex 8-track. And I remember one of the faculty on my PhD committee was frustrated with my lack of progress, and he said, getting a PhD is not a hobby, because he had heard that I was late for a meeting because I had a recording session at home. I loved having this little studio at home with the analog machine. And joining DigiDesign was, in fact, a weird stretch for me, because I was not enamored with computer-based recording. I was focused on putting good microphones in the right place and pressing record on an analog machine and saying, "Wow, this sounds gorgeous." So I thought of nothing else. I could work with ProTools and try and uphold the things that I felt passionately about in audio. And of course, everyone else at DigiDesign had a different background in audio, and a lot of them had very successful analog studios before Pro Tools as well.
And then I guess it was right after that, you took another completely different path back into chip design.
Yes, that's right. Although this was very directly motivated by high quality audio. So I left DigiDesign to join a small company that made we call them mixed signal semiconductors, but all that means is A to D converters and D to A converters, which are challenging designs because you want very high quality analog performance, but you have to combine it with some significant digital design, some significantly high-speed digital filtering, and you do that all on one chip. And so it's a unique kind of a chip designer that does that work. And at that company, I was not a chip designer, but a person connecting the audio industry with the products that we were making, and also the potential products that we were going to make. How do you figure out the right combination of features to put on a chip to meet the customer's needs? And I think one part of that I didn't expect would be so interesting was the manufacturing workflow. When these chips are manufactured, you need to test them and make sure that they're all meeting the specs, and that's a very challenging test to do in a manufacturing environment because it has to be fast and it has to be accurate. And those test machines cost an immense amount of money per hour, so you can really end up burdening the chip cost with manufacturing time if you don't do it well. So I think one of the things I liked about that is the cross-disciplinary debugging, which is I find really true in acoustics as well. I love debugging across different domains. And there were times when I'd feed a tray of 500 chips into this robot, and it would carefully put them in the test fixture and put them all in the bin labeled bad. It's like 500 bad chips. It was depressing because I had to ship these things to someone, and I knew that some of them were good. And of course, this was, many weeks of going back and forth in the lab where I would hand test these chips and then run them through the manufacturing flow and try and get the same results. But the things that would go wrong were of so many different flavors. The test flow was written in some components in C++. So I'd spend time with the C++ debugger, stepping through and trying to find out whether the code was broken. But of course, there's, very low THD analog electronics on the test fixture. So I was debugging with an oscilloscope and debugging these very high quality amplifiers, trying to make sure that wasn't a source of problem. But then sometimes the robot would put the chip into the test fixture with the wrong force, or something would be wrong with the packaging or the physical aspects of the test fixture. So I was debugging with a very high-powered microscope. I mean, I wasn't debugging the die. We had the chip itself working, so it wasn't an electron microscope. But, I'd sit there in this really complicated test facility trying to figure out what was wrong, and I'd bounce between these three domains, and it was very challenging, but terrific fun because of it. I thought that was really neat. And eventually I'd run 500 chips through the thing, and we'd get some percentage of good chips, and we'd ship them. And at that point you begin getting the test flow to be faster and faster, and making sure it correlates with lab results and that sort of thing. It was a very unusual company because we made a lot of devices that were not audio devices. Some of them were just diced wafers, like very high channel count D to A converters. In one case, a very high-speed network back-end link that was done on contract for another company. So it was a really full, there's a better way to put it, it was a semi-custom chip company that made some catalog products and some unique products for individual customers. It was a neat experience.
I think for those of us that utilize the end product of these kinds of chips that you were working on, fail to realize just the complexity involved, not only in the design and getting it to work well, but also, of course, in making it sound good. But in addition to that, just the challenges of manufacturing these things consistently so that there's a steady supply. And, for those of us at the other end of it, it's just a box we put in the rack and plug in. And that's the end of our concern with it, as long as it works and sounds the way we want it to. But there's a lot more to it.
Yeah, it's complicated all the way from the design side through manufacturing. And even on the design side, I think high-quality audio is very, very hard to design, in part because the simulators can't give you a real predictable output. And I say that carefully because there's two parts of it. Is first of all, a simulator isn't going to tell you how something sounds. So of course you've got to listen to it. And by the time you've committed to the mask set and fabricated wafers, it's not like you can say, well, that sounds a little wonky. Let's go change that. I mean, you do, but that's not a fast design cycle. But also, it's not possible to simulate an audio path of that precision in a circuit simulator. The simulator itself will reveal design faults and will give you some measure of THD and things like that. But I think modern A to D converters, and I may be wrong by now because it's been a good 10 years, but I think modern A to D converters far exceed the performance of the simulation predictions. And that's good. It's actually a really cool design space because of that. The simulator is a tool, but you really have to iterate the design and listen carefully and Of course, no A to D converter stands on its own without good board-level analog design around it and good power supplies and clocks and all that stuff that's well outside of the chip itself. So from a systems point of view, I think those things are very challenging to design as well. It's what I like about microphones, too. It's quite cross-disciplinary. It's got a lot of basic physics. It's got a lot of stuff you can simulate, but it's got a terrific amount of performance that the end customer cares about that can't be predicted until you go through the design iterations.
Well, there's so much in audio that comes down to what does it sound like, and that, I think that's what always makes a difference between products that are acceptable, mediocre, certainly worthy of use, and those that are exceptional. So it's nice to know that even in that highly technological process of designing chips, that there's still the human element of what does it sound like.
And I think it applies to, as I say, transducers, but another example that comes to mind is buildings. If you're going to make a concert hall, that's a multi-year effort. It's one that has very, very subtle perceptual elements to it in the outcome, and a simulator is, of course, an absolutely crucial part of that design flow, although they didn't have simulators way back when, and they certainly made good concert halls back then. But the process of making a good concert hall involves so many elements of experience and academic background and simulators and collaboration with large teams of people. It's really amazing to see. I think semiconductors, transducers, and buildings, yeah.
Even with all the design tools and experience that we have, concert halls still to this day tend to require a lot of after construction fine tuning to get to the performance that they're looking for.
Yeah, they sure do. They do, yeah. And when that goes really wrong and you say, well, why is this happening? And you try and look back at the part of the design flow that didn't expose this part that needs fixing. Sometimes it isn't something you could have simulated, and sometimes it's something you could simulate, but maybe there were factors that prevented you from building it right the first time. Like, I don't need to speak poorly of contractors, but sometimes the contractor doesn't follow the instructions. That's an interesting problem. Sometimes the contractor follows it absolutely correctly, but the design was wrong, and sometimes people change their minds, like, oh wow, our budget changed and suddenly we need a different building. I don't know how often that happens, but it's it's kind of remarkable how it's never what you think when you start the project.
Right. And I think the fact that we have great sounding concert halls to some extent falls into that category of, they don't build them like they used to. And the reason people say that is because whatever it was, the house, the concert hall, whatever, that wasn't designed and built well, didn't survive for hundreds of years. And so we don't even know about all the failures.
It's true. There are plenty of failures in the years past. We just don't pay attention to them.
That's right. They're lost to history.
That's interesting. Yeah.
But I want to get into, your most recent venture into the audio world, and that was in the microphone field, which seems to me to finally bring you right back around to your original acoustics interest.
Certainly, yeah. I've been until recently with Sennheiser's research laboratory here in North America, and my work there is focused mostly on microphone arrays, which as much a transducer modeling problem as it is a signal processing problem. So it's an interesting fusion of those two things. And in general, I've found that microphone arrays don't get a lot of attention in pro audio for lots of reasons, including lots of good reasons. But for the most part, I've worked on microphone arrays that are used for teleconferencing or I would say de-reverberation, in the sense that you use a microphone beamformer to pick up a specific person in a room trying to eliminate the reverb of the room so that the person sounds good at the far end. And it was a very interesting design space because there were lots of things to address in there. There's, of course, the physics of the acoustics in the room and of the microphones themselves. And then there's the signal processing of the signals from the microphones. And I also contributed, probably more than anything else, to the system architecture of how to make this thing run in real time and make it usable and shippable as a product, even though our charter in our laboratory was to create prototypes and try out new ideas. It's certainly to the credit of the design engineers in Germany to turn it into a product, but it's worked very well.
I want to ask you another question that's a little off the wall, but I'm interested in your response to this. We have pretty high quality gear in the recording studio. We've got great microphones, preamps, converters, workstations, loudspeakers, all that stuff. In your opinion, because you've worked across so many of the aspects of that, what do you think is the weakest link in providing the highest quality audio? I mean, where is there the most room for improvement?
What a very interesting question, and it's especially interesting because I didn't see it coming, or I certainly don't know ahead of time.
I purposely didn't tell you that.
Exactly. Yeah. That's right. Well, I'm going to lean right on the room acoustics part, which is, I don't know if that's sidestepping your question, but it's an important part of the. I mean, I don't know whether to call it the signal chain, but it's an important part of the result of recording is recording in a good environment. And what I find most interesting about putting a microphone in a room is that it's a huge collapse of information, in the sense that there's this very complex acoustic field surrounding a musical instrument as it's played, and then, of course, further created by the room in which the instrument's played. And I guess I'm saying it that way because even if you were to record a musical instrument in an anechoic chamber, the complexity of that field is huge, and it's completely collapsed when you put a microphone in a single location and near that instrument. So to actually capture that acoustic field is something we don't do typically, and that's okay. I think music production is about creating a very carefully crafted experience to the listener at the far end, and there's no requirement to capture the full field. In other words, it's not a medical imaging problem. It's not an automotive engine design problem where you need to map the full acoustic field on the whole thing. You can put a good microphone in front of a guitar and it will sound exceptional. But it is a place in which we are discarding or not able to capture the full information. And the information that exists within a room is immense as well. A great example is how well you can find the boundaries of a room with your eyes closed, because we can hear reflections very, very well. And a lot of that is not included when you use a single microphone. And in pop music recording with close mic'd instruments, of course, you're really trying to get the room out of the way. But that to me is when it's done well, it has a huge impact on a good recording. And when it doesn't work well, you can hear it. Maybe in pop music recording, this is less germane to your question, because at that point the signal processing and the creation of an exciting work is entirely after the microphone at that point. I don't know.
Well, that's an interesting perspective, and we didn't discuss this before, so I wasn't sure what you were going to say, but I have to say I agree with you completely. And I would point out that the room is always there, no matter how close mic something is, how subtle that room contribution is, it's still there. and it may be a subliminal clue, but it does contribute to the listener's perception of the space. And they'll never realize it, and even those of us in the business, probably it's unconscious most of the time. But just like you say, you can walk into a room with your eyes closed and know where the walls are. I think that same degree of perception can be applied to listening to a recording, that you are hearing the room, even if you don't consciously hear it. It's still there.
Yeah. So that all of that happens before the microphone. And of course, there's so many different kinds of recording as well, right? I mean, in some cases, the room is such a relevant and beautiful part of it. I mean, I find in choral recording, the connection to the talent is just stunning. There are people in a room singing, and you put microphones there, and to be able to reproduce that later feels absolutely magical to me. And I certainly do think that production of audio for film is also magical, but it's a completely different process. That stuff is absolutely fascinating to me in completely different ways. But the magic of just a small number of microphones in a good acoustic environment with talented performers is I think still hugely motivating and magical to me. And I wonder, if I go back to the way you phrased the question, is there anything I would change about the microphone or the amplifiers or the A to D converters? I think that stuff is really, really, really good. Like almost to the limit of physics, except that when you do push past that, it's not necessarily commercially relevant. And I say that carefully because, it's possible to make microphones that might extend their performance envelope in different ways, but it's not necessarily something that people are reaching for, because they're already at the limits of what's good in audio. I wonder if that's a controversial opinion. I mean, you can't use a conventional audio microphone to do medical imaging. It's not designed for that. So you have to design the transducer for the application. So maybe one way to think of your question is, are the products used in professional audio, everything from transducers to electronics, are they now at a point where they're good enough and we need to focus on something else? Who's the we there? If there's something new to be made in pro audio, is it performance related or is it more creative flow related? And so I think that a lot of the energy now is focused on creative process and how to use the tools that we have, given how quality they are.
Right. Well, that could lead into a long discussion of the purpose of recording. And
yeah,
I've always felt that we're not necessarily trying to give people an exact replica of what happened in the studio, but we're trying to provide the best experience for them, which is different than just making it sound exactly like it was performed. So we do things to change that. And that I think early in my career, I was frustrated by that until, one day I came to the realization that that's not the goal. The goal is to make an effective recording.
That's right. It's a very interesting sudden. I remember that for myself as well. I mean, I'm so physics based that I keep thinking we're supposed to take this acoustic field and map it to some other location, and of course, that's just not what it is. Now, it is interesting to look at the ways in which virtual reality is attempting that. Full immersive audio is a completely different path from what you just described, except it's still a perceptual goal. You want to make the end user, well, you want to offer a range of feelings that's within the creative workflow, and some of the tools to do that for immersive audio might be different from what's traditionally used in music production as it's been done already. So there's a lot of room there. There's a lot of interesting direction to take that. But I think that's far beyond the scope of conventional music recording. And I think that also gets into what does it mean to create audio for cinema and to create an experience for the end listener, or, well, at this point, I guess I'm trying to say it's not just a listener, it's a person with many senses. And how do you offer that person an experience? It includes an auditory experience, includes a visual experience, and a tactile experience. And how do we fit into that as practitioners of audio to make that as compelling as possible? It's where I know a lot less about audio production for cinema, but I see the magic that occurs there, and I'm truly impressed by that. I think as long as the right tools are available, microphones and the right chips and software and stuff like that, those are the tools. But what's done with it is exceptional. It's really, really neat to see.
Is there anything that we didn't discuss that you think is important to our conversation?
One thing we haven't talked about much, because it has really not much to do with equipment design or software or anything like that, is just the human experience of listening to music with other people. And to me, it really does come back to that. I think that's what has always motivated me or brought me to a realization of how human this is and how connected we are as people. And I think it's absolutely amazing that there is this ability to record and reproduce audio, but it is really significant that people sharing music together is so powerful. It's particularly odd to me that in these times we can't really do that the way we used to. So that's a very strange thing. I have no constructive comment about it except this recognition that as much as I like spending time in studios recording music, it's now really significant in terms of sharing music. It's really different.
Well, I think you hit on a really good point, and that is that we can talk all day about the tools we use, but the fact is, if there wasn't music, we wouldn't be doing this. It's all in the service of making that emotional connection between the person making the music and the person listening to it. It's easy to lose sight of that, but I think that we always have to keep that in mind.
Yeah. It's a very powerful thing, and it's what has really kept me close to the industry the whole time. Even though I love the tangents I've taken, it's really fun to come back to that original experience. And I think it's also powerful even beyond music, just the idea of telepresence, and I want to say that as high quality telepresence. The ability to be immersed in some remote environment, I think is really compelling, and there's plenty of work to be done there. But it's a field of so many dimensions. It's neat.
I've been talking with research engineer Tad Rollow. Our conversation was recorded at 24-bit 96 kilohertz PCM. Tad was recording in his home studio in San Francisco using a Sennheiser MKH8050 mic into a Fearn VT-2 microphone preamplifier and recording to ProTools. I'm using an AEA R44 mic, a VT-2 preamp, and Emerging Technologies converter recorded to Pyramix. The mix was processed through a Fearn VT-5 equalizer and VT-7 compressor. Your comments, questions, and suggestions are always welcome. You can send email to dwfearn@dwfearn.com. The link is also available at dougfearn.com. This podcast is available on Apple Podcasts, Stitcher, Spotify, Google Podcast, and many others. Any of their apps allows you to listen at any time, automatically download new episodes, and even receive a notification when a new episode is published. And you can rate the podcast and leave a review. This is my take on music recording. I'm Doug Fearn. See you next time.